our last video, we talked about what percent by mass was, and we said it was the mass of solute per 100 mass units of solution. Today we're going to look at 4 example problems that use percent by mass and density in calculations. So our first example problem states, calculate the mass of NiSO4 contained in 200.0 grams of 6.00% nickel 2 sulfate solution. So we know that this right here, we want the mass of NiSO4. This is our solute. We're told that we have 200 grams of 6% solution of nickel 2 sulfate. This 6% tells us that we have 6.00 grams of NiSO4 dissolved per 100 grams of solution. So we're going to use that as a conversion factor. So we're always going to start with a number that we're given. In this case, the 200.0 grams of solution. So 200.0 grams of solution. And we're going to set up a conversion table. And we want to cancel out grams of solution, so I'm going to put this grams of solution, 100 grams of solution, in the bottom so the units cross out. And the other part of our conversion factor is a 6.00 grams of NiSO4. So our grams of solution cross out. We're left with the units of grams of nickel 2 sulfate, which is what we want, the mass of NiSO4. So we just do the calculation. We can either multiply these two numbers first, then divide by 100, or we can take 200.0 grams divided by 100 and then multiply that by 6.00. We also have to pay attention to significant figures. Well, this measurement right here has 4 significant figures. Our percentage has 3 significant figures, so our answer is going to have 3. Go ahead and pause this and calculate and see if you got the same answer that I did. Welcome back. You should get 12.0 grams of NiSO4. That would be our answer. 3 significant figures. Our second problem, we have a 6.50% sodium chloride solution, and we're told that it contains 40.0 grams of sodium chloride. We want to know what is the mass of the solution. So again, let's look at what we're given. We are given 40 grams of NaCl. That is our solute. The 6.50 is our percentage, which is our conversion factor, and we're looking for the mass of the solution. So we're going to start with what we're given, 40.0 grams of NaCl. Now our 6.50% tells us that we have 6.50 grams of NaCl per 100 grams of solution. So the 6.50 grams of NaCl goes in the bottom, so our units cross out, and the 100 grams of solution goes up on top. So our grams of NaCl cross out. We're left with grams of solution as our unit, and now we have to do the math. You can go ahead and pause and see if you get the same answer as I do once you unpause the video. So I got 615 grams of solution as our answer. Our third and fourth examples are going to contain density. If you remember, density is a way we can go from mass of the solution to volume and vice versa. So our first problem says calculate the mass of copper 2 sulfate present in 200.0 milliliters of a 3.50 CuSO4 solution if the density of the solution is 1.06 grams per milliliter. So in this case, we're given milliliters of solution. So we know that we use density as a conversion factor. The other conversion factor is our 3.50%. So the only other number that's left, the one that we're going to start with, is 200.0 milliliters of solution. Now we want to get rid of those units of milliliters. So 3.50% means that we have 3.50 grams of our solute copper 2 sulfate per 100 grams of solution. We do not have a unit of milliliters here, so we can't use that conversion, but this one we can. The density means that we have 1.06 grams of solution per milliliter. So we want milliliters to be in the bottom. That means that the grams of solution are going to go on top. Well, 1.06 grams per milliliter, that's 1 milliliter. So there's our first conversion. And our units of milliliters of solution cross out. We're left with grams of solution. But we want to calculate the mass of CuSO4, not solution. So we have to get rid of the grams of solution. So we're going to use our conversion factor for the percent by mass. So we have 3.50 grams of CuSO4 per 100 grams of solution. I want to get rid of grams of solution, so the 100 grams of solution go in the bottom, and the 3.50 grams of CuSO4 goes on top. Our grams of solution now cross out, and now we have to multiply our numbers that are on top, divide by any numbers that are on the bottom. If you want to pause this to see if you get the same answer that I do, please go ahead. So when we calculate this, we have to look at the number of significant figures. So we have three different measurements here: 200.0, 3.50, and 1.06. When we multiply and divide, if you recall our significant figure rules, it's the least number of significant figures. This one has 4, both of these have 3, so our answer should have 3. And when you do the math, you should get 7.42 grams of CuSO4. Make sure that you're putting labels and units on your numbers. So our last example, what volume of 15.0% ferric nitrate solution contains 30.0 grams of ferric nitrate if the solution has a density of 1.16 grams per milliliter? So in this one, we know that we're not going to start with the density because that's a conversion factor. And we know we're not going to start with the percentage because that's also a conversion factor. So the only thing we're left with is the 30.0 grams of ferric nitrate. That is the solute, it's not the solution. The biggest mistake that people make is they mix up what is a solute, what is a solution. This does not say solution after it, so we know that it's the solute. So we start with our 30.0 grams of FeNO3. And as you can see, there's a little mistake or a typo here. There's a missing 3 with the ferric nitrate. So you can go ahead and put that in. So we start with that. We want that unit of grams of FeNO3 to cancel out. Our density does not have grams of solute in it. It has grams of solution. So we have to use our 15.0%. Because that tells us that we have 15.0 grams of ferric nitrate in 100 grams of solution. So we put the 15.0 grams of FeNO3 in the bottom and 100 grams of solution on top. That cancels out our grams of FeNO3 and we're left with units of grams of solution. Now we want to get rid of grams of solution and we want volume. Well, we know that milliliters is a volume. So we're going to use this density, 1.16 grams of solution per 1 milliliter of solution. We want grams to cross out, so grams of solution will go on the bottom. And we know that 1.16 is the measurement that goes with that. And 1 milliliter of solution goes on top. That allows us to cross out our grams. Our answer will be in milliliters. You can pause here, do your calculations, and report your answer to the correct number of significant figures and with the correct unit and label. So when we look at this and we multiply and divide as needed, we know that our units are going to be milliliters of solution. So when we calculate this, if we look up above in our problem, everything has 3 significant figures. So our answer has 3 significant figures, and it's 172 milliliters of solution.